This is an example of using binomial distribution in a word problem. In this question, it's from page 385, number 5. It says the faces of a 12-sided die are numbered 1 to 12. What's the probability of rolling 9 at least twice in 10 tries? Okay, so we have 12-sided die, and we want to roll 9 twice. At least. That's key. Not twice, just period, it's twice at least. Well, it would be helpful to know, although it should be pretty straightforward, what's the probability you roll a 9? Well, the probability, I wrote little p here, it's not a capital P, it's little p as in binomial distribution. We usually use p to be success. What's the probability of you being successful? That's the number of ways you can roll a 9, 1, out of the total number of ways you can roll, 12. Which means the probability of failing to roll a 9 means you roll one of the other 11 numbers out of 12, or a failure probability of 11 out of 12. Okay, so back to the question. What's the probability we roll at least 2 9s, or 9s twice? Well, that's going to be hard to calculate straight. That would have to calculate the probability of 2 9s, or 3 9s, or 4 9s, or 5 9s, 6 9s, all the way up to getting 10 9s. I forgot to write down here, we're doing 10 rolls. So you wouldn't want to do those 9 cases, 2 9s, 3 9s, 4 9s, 5. That's a lot of cases. Instead, it's a lot easier to use the indirect method and say the probability of at least 2 9s is 1, take away the probability of no 9s, take away the probability of 1 9. That is, if you want to know what's the probability of rolling at least 2 9s, you can just do 100% take away the probability of rolling no 9s and rolling 1 9, and everything left over will be 2 9s or more, which is what we want. So we just go 1 minus the probability of rolling no 9s, and we use binomial distribution. What's the probability of rolling no 9s? Well, we have 10 rolls, and we want to choose no 9s. So that means we want to choose no successes. So that means our 1 out of 12 probability of success gets no successes, and our 11 out of 12 probability of failure happens 10 times. We 10 times fail to get a 9. Minus, what's the probability of getting 1 9? Well, it means of your 10 rolls, choose one of them to be a 9. This also just comes from the formula. So that probability of getting a 9, 1/12, happens once. And the probability of not getting a 9, 11 out of 12, happens 9 times. And now we just need to calculate those. What's 10 choose 0? That should be something you remember is just 1. Also, anything to the power of 0 is just 1. So we just go, what's 11 divided by 12? And then raise that to the power of 10. And we get, let's write that decimal down, put a rounding dot. Let's do 5 decimal places, 41890 approximately. Minus, now what's 10 choose 1? You should know that that's just 10, but you can type it in. 10 choose 1 times, you don't need brackets here, but I'll just put it for clarity's sake, times 1 divided by 12. I'll hit equals. I'm going to put brackets here though, just to be sure my exponent ends up only on the 11 out of 12. So times, and I want to put brackets, 11 divided by 12, and raise that brackets to the power of 9, equals, and I get 0.38082. That's the probability of getting 1 9. So what's the probability of getting at least 2 9s? It's just 1 take away those two numbers. So it's 1 take away 0.41890, don't really need the O, minus 0.38082, and you get 0.20028. Therefore, the probability of getting at least 2 9s is approximately, let's move this over 2 spaces to make it a percentage, 20.028%. And so what we've done here is solved a binomial distribution word problem using the binomial distribution formula.